Okay, welcome to lesson 25, problems for lesson 25, where we are going to practice problems of integrals that the solution, the antiderivative of the function, will be related to the logarithm of the function. So we start with problem 1. Problem 1, it's what is the integral, what is the antiderivative of the function 1 divided by 2x plus 5? It's a function whose derivative is 1 divided by 2x plus 5. How I will find this function? Maybe substitution will help us. But indeed, just looking at the function 1 divided by the function, by the derivative of the function, that will be 2. You can say that this is the logarithm of some function. So we do substitution, u equal to x plus 5. So ddu is equal to 2 times ddx. So ddx is 1/2 of ddu. So we rewrite the equation in terms of u, and it will be 1 divided by 2x plus 5 ddx. It will be 1/2, 1 divided by u by ddu. 1 divided by u by ddx, which is 1/2 ddu. 1/2 ddu. 1/2 ddu is ddx. And 1 divided by 2x plus 5 is 1 divided by u. So now I can do the integral. The integral of 1 divided by u by ddu is the log of u. Log of u plus c. So now the problem is not finished yet. The problem is finished when we change u by 2x plus 5. So the final result will be 1/2 log of 2x plus 5 plus c. And again, you can check if this is true by making the derivative of this expression. If you make the derivative of this expression, you should find 1 divided by 2x plus 5. Next problem. Find the indefinite integral of x squared minus 4 divided by x. So you make a little bit of algebra, and x squared divided by x is x. 4 divided by x is 4 divided by x. So this expression is the same expression like x minus 4 divided by x. The antiderivative of x is x squared divided by 2. The antiderivative of 4 times 4 divided by x is 4 times log of x. So the final result is that the antiderivative of this expression is x squared divided by 2 minus 4 times log of x plus c. If you want, you can put it like this also. Minus log of x plus log of x minus 4. Okay. Okay. The third problem is find the indefinite integral of x squared minus 3x plus 2 divided by x plus 1. This is the division of two polynomials. We can use long division to do the division of two polynomials. And in general, the division of two polynomials is not a polynomial. It's a rational function. So remember that when you divide 10 divided by 11 divided by 5, this is 2, and the remainder is 1. So 11 is 2 by 5 plus 1. This is 11. So it's this by this plus 1. So when you have the division of two polynomials, p of x and q of x, p of x divided by q of x is c of x, and there is a remainder. P of x is always c of x multiplied by q of x, this plus this multiplied by this plus this multiplied by this plus this. So p of x divided by q of x, the division of the two polynomials is c of x plus r of x, the remainder, divided by q of x. Okay, so if you do long division, that I hope you know how to do, the division of the two polynomial, it will be x minus 4 plus 6 divided by x plus 1. So instead of trying to calculate this, you calculate the integral of these two terms. And the integral of these two terms is x minus 4 plus 6 times 1 divided by x plus 1. So x will produce x squared divided by 2. Minus 4 will produce minus 4x, like the antiderivative. 6, this is the log of x plus 1. The natural log of x plus 1, the derivative is 1 divided by x plus 1, so the final result will be this one. Now, this following problem is to find the integral of tangent 5 theta by d theta. Well, tangent of 5 theta is sine of 5 theta divided by cosine of 5 theta. Cosine of 5 theta is in the denominator. So it's 1 divided by the function, by the derivative of the function, that is sine. The derivative of cosine is sine. So this looks like a logarithm. So let's go to do it. So the integral is the integral of sine of 5 theta divided by cosine of 5 theta by d theta. Cosine of 5 theta, sine of 5 theta, that is in the numerator, is the derivative of cosine of 5 theta, but we are missing a 5. So we need to put a 5 here, like 1/5. So this will be the logarithm of cosine of 5 theta, and the minus sign comes from the fact that the derivative of cosine of 5 theta is minus sine of 5 theta. So because this minus is not here, I will put it here. So now I may say, what is the derivative of minus log of cosine of 5 theta? It's 1 divided by the function, 1 divided by cosine of 5 theta, by the derivative of the function. The derivative of the function is minus sine of 5 theta plus multiplied by 5. So this is not the integral of tangent of theta unless I put 1/5. So now the derivative of this will be tangent of, the derivative of this will be tangent 5 theta d theta. Okay, let's go to the next problem. Now we are going to practice this integral, the integral of sine x tan x divided by sine of x minus 1. And we are going to use substitution. If you remember, the derivative of secant x squared, of secant of x, is secant x tan x. So it seems to me that here there is a logarithm of secant x. There is the logarithm of secant x minus 1, because the integral will be related with the log of something. So let's go to do it. We use substitutions. The substitution, and we take u like secant x minus 1. So the function u is in the denominator, and the derivative of u respect to x is secant x tangent x. So d du is secant x tangent x ddx. So d du is sitting down in front of you. So this is d du secant x, and this is u. So the equation will be 1 divided by u d du. Wow. So let's go to open this. The integral will be the integral of d du divided by u. What is the integral of d du divided by u? Oh, is the log of u. So the integral is the log of u. So log of u plus c is the integral of this. Is the problem solved? No, not yet. U is secant x minus 1. We have to substitute what is u. So the final solution will be log of secant x minus 1 plus c. And this is the integral of this problem. Next problem will be to solve the derivative of y respect to x. The slope is 3 divided by 2 minus x, and this remains a logarithm because the slope is 3 divided by 2 minus x. The slope of the logarithm function is 1 divided by x. So how we will do this thing? We have to find y whose derivative is 3 divided by 2 minus x. This is a differential equation. So how we will do, let's go to separate. Separate. The y will go to one side and ddx will go to another side. If we make the separation, it will look like this. Now we make integration in the left side of the equation and in the right side of the equation. The integral of dy equals the integral of 3 minus 2x. We keep going, and the integral of dy is y of x, and the integral of 3 goes out of the integral, and the integral of 1 divided by 2 minus x is log of 2 minus x with the minus sign. So it's minus 3 by the log of 2 minus x. So the final answer is that y of x is 3 minus 3 times the log of 2 minus x plus c. Now we want to calculate, problem 7, the integral from 1 to e, from x equal 1 to x equal e, of the function 1 plus log of x, everything squared, divided by x. How we will find this integral? You know, we can use substitution. So, if we name u as what you will name the u? If I name u equal 1 plus log of x, the derivative of 1 plus log of x will be 1 divided by x. And now 1 divided by x ddx is sitting down in front of you, and this is ddu. So let's go to do it. We use substitution. We name u like 1 plus log of x. So ddu ddx is 1 divided by x, so ddu is 1 divided by x by ddx. So here is ddu. ddu is 1 divided by x by ddu. And here is u squared. So the integral will be the integral of u squared ddu. Oh, sorry. Now, this is ddu, and let me put this, I don't know why I wrote like this. Okay, now we keep going, and we do the integral from x equal 1 to x equal e is the same integral that the integral of u squared by multiplied by ddu. But now we have to be careful with this. When x equal 1, the substitution, we have substitute u by 1 plus log of x. When x equal 1, log of 1 is 0, so u is equal 1. But when x equal e, the upper limit, log of a is 1. So u at x equal e is 1 plus log of e, 1 plus 1, which is 2. So the integral will be from x equal 1, from u equal 1, from x equal e, from u equal 2, of u squared ddu. So this is u cubed divided by 3, between 2 and 1, and this will be 2 cubed divided by 3 minus 1/3 divided by 3 will be 7/3. Or if you prefer to do the first, if you prefer first to do 1 plus u cubed, and you substitute on u cubed, u is 1 plus log of x. If you substitute from x equal 1 to x equal e, the result should be the same thing. It will be 1 plus log of e is 1, 2 cubed is 8 thirds, minus log of 1 is 0, 1 cubed is 1 third is the same thing. Okay, let's go to the next problem. The next problem is about the integral of a quotient of a division of two polynomials. The first polynomial is x minus 1, the second polynomial is x plus 1. We do long divisions, and you know that when you divide p of x divided by q of x, the remainder and c of x, the relation is that p of x is c multiplied by q by r. So p divided by q, c of x, is c of x, plus r of x divided by q of x. So we divide, we have c of the division between this and this is c of x is 1 plus r of x minus 2 divided by q of x. Q of x is x plus 1. So now I can do the integral. Now the integral will be the integral of 1 ddx plus minus 2 divided by x plus 1 ddx. The integral of 1 ddx is x. The antiderivative of minus 2 divided by x plus 1 is minus 2 log of x plus 1, and it's the definite integral from 0 to 1, so you don't need the c, you don't need the c. So you evaluate between 1 and 0, between 1 is, for 1 is 1 minus 2 log of 2, 1 minus 2 log of 2, and for 0 is 0 minus log is 0. From 0 is 0 minus 2 times log of 0 plus 1, that is 1, log of 1 is 0. So it will be 0. And the next problem is find the area bounded by x equal 1, from x equal 1 to x equal 4, and find the area under this curve, x squared plus 4. So you divide x squared divided by x is x, 4 divided by x is 4 divided by x. You make the integral, very easy integral. You evaluate between x equal 1 and x equal 4, and the result will be here. This is the result. 15 divided by 2 plus log of natural log of 256. And now is another problem is find the average value of f of x equal a divided by x squared in the interval 2, 4. So you have the function 1 divided by x squared, or a divided by x squared, and you need to find the average value between 2 and 4. Between 2 and 4, when it's 2, the value is a divided by 4 is 2. And when it's 4, the value of the function is 4 squared is 16, a divided by 16 is 1/2. So the average value is between 2 and 1/2. So 2 is here, and the 1/2 is here, 1/2. And the average value is somewhere between 1/2 and 2. The average value is the value that when you calculate the area of the average value is when you calculate the area between 2 and 4, you make a rectangle. The area is the same area that is the area below under the curve. So the equation is saying that the area of the value f of c, this is f of c, this is f of c, the average, we put it maybe a bar, also we can put it f of c like this, the average value. Okay, the average value f of c by v minus a, 4 minus 2, is the area under the curve. So let's go to find v, f of c. The average value f is 1 divided by v minus I by the integral from a to b of f of x ddx. So it will be 1 divided v minus a, 4 minus 2. 4 minus 2 is 2. F of x is 8 multiplied by x minus 2, x minus 2. And if you make the calculation, it will be the average value will be 1. So it will be next to the 2, more next to the 2, more next to f of 2, to f of 2, which is 2, than next to x of 4, which is 1/2, is more here. Okay, and the average value is 1. The average value is the value that between 2 and 4, if you substitute the function a divided by x squared by an horizontal function whose height is 1, the area will be the same. So the area is 1 multiply the area when you consider f average. The average is 1 by v minus a, is the area of the rectangle. So the area will be 4 minus 2, which is 2. The area is 2. And the area from 2 to 4 of the function is a divided by x squared ddx, should be also 2. You check. Okay, next problem. Show that f of x equals square root of x minus 4 and g of x equals x squared plus 4. They are inverse function when x is positive. X should be positive. Why x should be positive? Let's go to see why x should be positive. So g of x, and now f of g of x. So f composed with g of x is f of g of x. F of g of x is x squared plus 4. So it's f of x squared plus 4. And f of something is the square root of something minus 4. So f of something is the square root of something, x squared plus 4, minus 4. Oh, this is x. So they look that they are inverse, but to be inverse, we need to check also the composition of g composed with f. G composed with f of x is g of f of x, but f of x is a square root of x minus 4, and g of something is something squared plus 4. So g of something is something squared plus 4. Something squared is a square root of x minus 4 squared, is x minus 4 plus 4 is x. So I have proven that both functions, they are inverse function. Sine of x and arc sine of x, they are inverse function. In the interval where they can be inverse function, that is the interval where the function is 1 to 1, that is the interval between minus pi divided by 2 and pi divided by 2. So let's go to do, I hope, the last problem. I hope so, yes. Does the function f of time has an inverse function? Well, why or why not? Well, tangent of x is this function. Between pi divided by 2 and minus pi divided by 2, is they have an asymptote. They go to plus infinity. Here they go to minus infinity. And the function repeat is a periodic function. Okay, this is tangent of x. So the question is this function tangent of x have an inverse function? Well, from this x, the function f of x, tangent of x, will be this one. So this point will be tangent of x. If it exists an inverse function, the inverse function will do this. Will do the opposite thing. We'll take the tangent x, this number, and we put it in the x. The problem is that when you are here, you can go also here, and you can put the numbers in many places. So to restrict this, we need a function that is one-to-one. So what we need is that we can restrict the region to be between pi divided by 2 and minus pi divided by 2. So tangent x have an inverse if you restrict the existence of the function between minus pi divided by 2 and pi divided by 2. So the function is not one-to-one. However, if we restrict the domain to minus pi divided by 2 by pi, then it has an inverse. And the inverse is called arctangent. So arctangent is the inverse. In what way? You start with the x. The function place the number y and put the number x here. So, and now arctangent of x is the function, the inverse function, who's putting the number in x. So the arctangent of x is the one that places the number on x. Arctangent, let me write it correctly. So the x, I apply tangent of x, and I'm here. Now I apply arctangent to this number, to tangent of x. And when I apply the function arctangent, the inverse function, I will produce the x. Oh, I think you know this. Okay, let's go. Okay, let's go to the next chapter soon. Goodbye.